Welcome to this explainer. Today, we're unpacking the architecture that quietly runs almost every Windows enterprise network in the world: Active Directory Domain Services, or ADDS. Since ADDS is literally the foundation everything else sits on, we're going to do this right. No rattling off vocabulary words. We're looking closely at the actual structures that make it tick.
To truly manage your infrastructure without relying on guesswork, we need to build a really clear mental picture of how all these ADDS pieces fit together. This is the system that lets you logically organize and physically secure thousands of enterprise objects, everything from user accounts to computers. Once you see how the logical and physical components interact, managing the infrastructure stops being this giant puzzle and becomes a system you can actually reason about.
Okay, let's dive into our roadmap for today. First, the foundation of ADDS. Second, partitions in the database. Third, the logical blueprint. Fourth, domains, trees, and forests. Fifth, the physical reality. And finally, connecting that blueprint to the building.
Part 1. The foundation of ADDS.
Let's start at the absolute base level. At the very heart of ADDS is a central database acting as the core store for every single object in your domain: user accounts, computer accounts, groups, the whole shebang. But what's really interesting here is what people often underestimate. Yes, it gives you a searchable hierarchical directory so you can find things, but beyond just being a list of users, it's the vital mechanism letting you consistently apply configuration and security settings to thousands of objects at once. It's the engine that lets you deploy apps, lock down security, and enable remote access across your entire enterprise.
Moving on to Part 2, partitions in the database.
Digging one step deeper into the logic, we have to understand how domain controllers actually organize all this enterprise data inside that core store. They use things called partitions, or naming contexts. The database itself is actually just a single file named Ntds.dit, but inside that one file, you've got distinct partitions holding very different kinds of data. The schema partition holds the schema itself. The configuration partition holds config objects for the entire forest, and the domain partition holds the specific users, computers, and groups for that single domain. And what makes this so incredibly robust is that Active Directory keeps copies of these partitions on multiple servers, keeping them all in sync through replication. That means no single machine ever becomes a bottleneck.
Part 3. The logical blueprint. Now we're getting into the logical components. I really want to emphasize the difference between logical and physical architecture here. Logical components are strictly about the design, the rules, and the organization of your infrastructure. They are not physical hardware. Think of building a home. The Active Directory schema is your architectural blueprint. It's simply a set of rules dictating that a house must have walls and doors, or in ADDS terms, that a user object looks a certain way and has specific attributes. The directory objects, on the other hand, are the actual physical doors and the populated user accounts you construct based on that blueprint. When you're actively shaping this logical blueprint, you'll use two specific organizational frameworks: organizational units, or OUs, and containers. Both help you structure things, but here is the big distinction that trips people up all the time. You can delegate administrative rights and link group policy objects to OUs to apply settings, but you absolutely cannot link group policy objects to default containers. That's the hard line separating the two.
Next up, Part 4, domains, trees, and forests. Let's see how this logical blueprint expands into a much larger hierarchy. As networks grow, ADDS uses highly structured boundaries to keep everything manageable. The most fundamental of these boundaries is the domain. A domain is a logical administrative container for your objects, and it directly maps to that domain partition we talked about earlier. Think of a domain like a single, isolated household. It serves as your core administrative boundary where your specific, local users and computers live and are managed.
Now you can arrange those domains into parent-child relationships. A domain tree expands that single household into a contiguous family compound. It's a hierarchical collection where a parent domain and its children seamlessly share the same overarching family name, meaning their names flow together in a contiguous DNS namespace.
Finally, we have the forest. The forest is the overarching boundary wall encompassing all these diverse domains and trees. It ties everything together into one complete ecosystem. All the domains within a forest might have totally different names, but they share the exact same root, the exact same blueprint schema, and a common global catalog.
Visually, a forest encapsulates trees, and those trees encapsulate individual domains. Together, they create a perfectly structured logical blueprint that can scale to fit massive global organizations while remaining totally structurally sound.
Part 5, the physical reality. Okay, now that we have our logical blueprint perfectly drawn, let's make it physical. We need to look at the tangible pieces that actually map to real-world hardware and locations. The first and most critical physical component is the domain controller. This is an actual server holding a copy of the ADDS database, and it operates on a multi-master setup. That means there is no single master server. Every single domain controller can process changes and then replicate those changes out to all the others. Each controller stores that directory information locally using Microsoft Jet database technology tucked inside that Ntds.dit file, usually sitting right in the Windows NTDS folder. Sometimes, physical hardware needs to take on specialized roles to solve real-world physical problems. For instance, within a large network, you'll rely on global catalog servers. These host just a partial, read-only copy of objects from multiple domains. Their entire job is to help you quickly find objects across different domains without making searches agonizingly slow. And then we have the read-only domain controller, or RODC. This exists for places like physical branch offices where physical security might not be great or IT support is thin. By placing a read-only installation there, you can securely run applications locally without ever risking a writable copy of your enterprise directory being stolen.
And finally, Part 6, connecting the blueprint to the building.
So, we have the logical concepts and we have the physical hardware. The final step is laying our logical architectural plans right over our physical building locations to see how they harmonize. To keep this totally clear in your head, always contrast these two specific terms, domain and site. A domain purely represents the logical structure of your users, groups, and computers. A site, on the other hand, strictly represents your physical geographic locations and buildings. It's a container for ADDS objects tied directly to a real physical place.
But how does ADDS actually know what physical site a computer is sitting in? Well, to tell ADDS exactly which physical site a computer belongs to, we use subnets. A subnet is simply a portion of your organization's IP addresses. By mapping raw IP addresses directly to those physical site containers, the system always understands the physical reality of where a machine is located.
And that brings us to the ultimate question. Now that you can clearly see the logical domains, trees, and partitions sitting perfectly on top of physical sites, subnets, and domain controllers, how will you use this foundation to architect your own enterprise network? Once you see these two layers, the logical blueprint and the physical building, working in tandem, Active Directory Domain Services stops being a pile of jargon. It becomes a powerful, structured system you can confidently build upon. Thanks for joining me for this explainer, and I hope this architectural roadmap helps you build your next network with absolute clarity.